programming languages. If you take a look at anything, it'll say pretty much at this point is Python, Java, C++ are the big ones. There's some other ones right below it, but where is Java used the most? It's not used in desktop applications. It's used in right here, Blackboard. One of the other big places that Java is used in is Amazon. So Java is used quite often in back-end coding for big websites. And later on, we're also going to work with SQL and Python. We're not going to get to SQL and Java because there's just, way too many things to cover. We will get to SQL. Does anybody know what SQL is? What does it stand for? What does it do? Yes, Jens?
That stands for SQL, and it's a programming language for creating databases.
Yes, it's a programming language for creating databases, and SQL stands for SQL. What does SQL stand for? Yes, Lyman, go ahead.
Structured query language.
Yep. It's structured query language. It's how 99% of the websites on the web use that to manipulate the databases in the back end. So SQL is literally everywhere. So it's something we're going to start putting in your tool belt. All right. And I do have, Copilot's off so I can do things. We are in if statements in Java. And as you have learned, the structure of a program in Java is slightly different than other programs. Every Java program has to have a class. The name of the class has to match the name of the file. So far, so good. We're always going to have this public static void, blah, 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 and we'll talk about that later on. But notice the keyword here that we've seen before in Python, main. Main is also in C++ because that's where the operating system looks for when you're executing the program. It says, is there a main function in here? Oh, there it is. I'll start the program. So without a main function, the typical Intel operating system doesn't know what to do. One of the things I ran into last week is at the top of your code, declare all your variables and constants. It's just a common way of doing things. And typically you declare your constants first. Declare your constants, objects, variables, and then go on to your program. Makes sense? In Python, we didn't have to declare things. But if you declare a variable and do something with it, now we're mixing things up. Try to, as much as you can, do one thing per line. This is not a contest to see how much you can do in one line. It is easier to debug code that's separated into different lines. I can tell you because I look at a lot of code every year, and it's easier for me if it follows kind of the same patterns everybody else uses. So far, so good? All right. So the naming convention for variables is lowercase. If your variable is longer, in Python, we did underscore. Well, in Java, we do capital letters. We have camel house. So we have camel casing. Kind of like we did with classes in Python, we do, the only difference between the class name and this is that you start with under lowercase letters. Why is it important to follow those conventions? Makes it easier for me to figure out what's going on.
For consistency.
Consistency, yes. If I'm looking at a bunch of code and it's consistent, I have a lot better, I can understand it better if I'm working on the project with you. If we stick to conventions, it makes it a lot easier for everybody to get along. If you have your own vibe of how you code and you write things, well, good luck getting somebody to work with you. You want to stick, and every company you work with is going to have some of their own conventions. And you want to adopt to whatever they have, because you're not going to be coding by yourself. Most of the time, you're going to be working in a team. All right, so we declare this integer, right? Age, we assign it right away. Do you have to assign something to a variable when you initialize it in Java? No, you don't have to. In this case, this is a hard-coded if statement. But I could just do that. It just creates an empty, it's full of garbage, a garbage memory area that I can use later on. In this program, we did what I call hard coding because we're not interested in input-output right now. We want to see how Java does if, else, and all that. Comprehensible so far? If it's not, let me know. All right. So notice that we have if, but we have little parentheses, and we have curly braces, and we have semicolons. These are just the rules of the road. If you can't remember how the program's shaped, do a quick Google, look at a previous program. This is what's called syntax. Syntax is the rules of how you type something in. So if a program doesn't run because your syntax is wrong, that's not a logical error. They call that a syntax error. So far, so good? Makes sense? If we add else, well, we have either this or this, right? Just like Python, no different. The logic is the same. And then we have, instead of elif, we have else if. Right? And the logic of all this is exactly the same as what we've done in Python. So when we get to C++, interestingly enough, the syntax of C++ isn't too far off from Java. Just like JavaScript syntax is not too far off from Java. You know, TypeScript, there's a lot of languages that use this curly bracket, semicolon thing. Python is one of the few that actually just uses sentences and words and tabs. But the concepts are the same. An if is an if, a loop is a loop. Just a matter of learning the new syntax. So far, so good. And then we have, compile. Oh, look at here. I'm making you do a command line thing. Whoa. What happens if you click the little run button here in Visual Studio Code?
You
It
get
does all
output.
this mumbo jumbo for you, and it runs the program. Uh-oh. So one of the things that we're going to work on in computer science, because computer science is more than just programming, we want to know why things work and how they work. So I'm going to have you do some compiling just like this. Whoa, what is all this? Well, let's go through how to do that. So Python is an interpreted language. It's a scripting language, which means you have to have a Python interpreter, which does make it run a little bit more slowly, but over time, they've made the Python interpreter much, much faster. In fact, version 14 is supposed to add a little bit of how Java does things. So Java has 3 layers. It has the program, right? And it does compile, but it compiles into what's called a bytecode file. So I'm going to bring up the terminal, which has a very long thing in there, doesn't it? So I'm currently in my folder. Whoopsie, I'm at the wrong place. I just wrecked my program. Didn't I? Yep. So it happens when you print in the wrong place, you wreck your program. There we go. So I'm in the right place now. dir shows me what's in my folder. Linux does ls, and we're going to do programming in Linux. If I want to compile and run the program from the command line in Python, I would type in Python space the name of the program, right? We haven't done that yet. I don't know if we ever not. In Java, we have 2 steps. We have to run the Java compiler. And we're going to run that against, I just will run it against if else. As I type in something, I can use something called tab completion, as long as I type in enough that Windows will recognize what it is and see how it pops in the whole thing for me. Saves a lot of typing, and it makes sure you don't type it in incorrectly. I was actually going to go to if else if, wasn't I? Tab one more time. There it is. Tab completion saves a lot of time. If you haven't done that before, I hope you're following along with me instead of doing homework. Yes, 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 just checking. Okay, so when we do this, it'll run for a second. And then if you do a dir, notice that we have a file that, oh, where did he go? Why isn't he showing up? We should have a hello world or a if then else. There he is. I just couldn't find him. So the class file is what's called bytecode, which means it's closer to the machine language. And what the Java runtime environment does is take that bytecode and convert it on the fly into machine language. Everything we run converts it into machine language. This is closer to machine language than Python interpretation is. C++ is closer to machine language than either one of these. So if I want to run the class file, Java, what did I do? If else, there he is. That will run the program. Uh-oh.
Java C.
No, it should just be Java. What did I do wrong? Oh, I don't run it with the class extension. There, you run it like that. Java automatically knows it's a class extension. Oh dear. What did I do wrong here? Class not found.
You sure it's not just Java, that Java? That's what a Java file is, not Java, not class.
Well, Java is working.
No,
Help us out here, Lon,
The,
Brandon.
the end prefix instead of class, it's Java.
You don't run the Java file, you just run it like this and it automatically finds the class file, that it is a class file, and this should run the program. Oh, I don't put the dot slash in there.
Oh,
There it is. So this part is kind of like Python. You type in Python, the name of the file, but in Python you do .py. This one you type in everything but the class file, and that runs the program. I just was having the slash and it didn't want it apparently. So anybody know what Sunset Bar and Grill references? Makes me old. It's an old Eagles song. Can't remember the exact song, but it's an old Eagles song. Can't remember exactly. I just, when I was writing, I said, oh yeah, Sunset Bar and Grill. All right, so there's how you can compile it if you wish. Moving on to, is it positive? That's pretty simple. Grades, okay. So, oh, I give you way too much here, don't I? So just like in Python, our logic structure is exactly the same. In C++, our logic structure is exactly the same. Right? We went through this some time ago. When you're doing decisions, you want to eliminate. Another thing that's called is binary problem solving or troubleshooting or something like that. Once we've determined, is the score greater than or equal to 90, do we have to test to see if it's greater than 90 ever again? No, we've eliminated everything above 90. We know that it's going to be between whatever it is and 89. So we never have to test it again. So we've eliminated everything from 90 up. You can also go in the reverse, eliminate everything from 0 down. Just remember, decision-making is elimination. Just like troubleshooting is elimination. You try to eliminate problems by, is it hardware, is it software? Well, now we split it in half. Once we know it's hardware, that dictates our next direction. It's the same thing with these guys. And then I think we do logical operators. Oh yeah, who doesn't like logical operators? So logical operators, laugh fest. Okay, I don't know what that one is. Oh, is it party time? Yeah. Sometimes I'm just too creative for my own good. So Boolean data type consists of, describe it, any of those things, Boolean data type. Give me what Boolean data types are. We used them in Python. We use them in every language. Go ahead, Owen.
oh no, true, false.
Yep. That's Boolean. And what we've done primarily to this point is we've used it in if statements and loops. But you can actually store true and false in a Boolean data type and use it later on. And that's all this is doing, is showing that yes, we can store it in a variable and print it out. And what's going to happen when we print it out? It will say true or false. Do we usually do that? No. I'm just use this just to say that yes, you can do it. Here we go. So how would you break this statement down? What is the order of operations for this Boolean expression of the term? Expression means that it's doing something. How'd you break it down there, Jens? How about you, Eliza? Anything? Christy? How would you break? What's the order of operations in this? What happens first? Caleb? Sean? Boy, we're very
Well,
quiet.
at the weekend, for that Boolean statement.
For this one right here, yep. What's our
Okay.
order of operations? What happens first? What happens next?
Well, it checks the date. And then if the date is a Saturday or a Sunday, 6 or 7, then it is the weekend, so it would be false. Correct? False, or is it true? Wait,
Date 1 equals 6.
so.
So this
it is-
particular thing, this particular big long
Yeah.
thing,
So it is true then, is weekend is
Right.
true.
it gets it by number. So date 1 equals 6, it's Saturday. If it's 7, it's Sunday.
So it is the weekend.
It's the number of the week. So it does that first. It does date 1. If that's not equal to 6, what happens next?
It skips it, because it,
No, I mean, if it's not equal to 6, that means it's false. What are we looking for? What are we looking for in a Boolean expression?
we're looking for. a
If
true
and else.
We're looking for a true. And if date 1 is equal to true, what you just said, Sean, is correct. We're done. We don't have to test anything else because we have or. That's called a short circuit evaluation. This is what it looks like in Java and many other languages. Python has literally the word or, which is not terribly common. So if this is true, we're done. That's called short circuit evaluation, meaning we don't have to test both of them. So if you're setting up an or, put your most likely case first. Well, in this case, it could be either one. If date 1 is not equal to 6, what happens next?
The testing too,
Yep. And if that's true,
and that's true.
then the whole expression is true. Is weekend has true in it. Now, if we change this to, let's see if anybody can remember what this one means. If I can find the key here, I got a lot of reflection. What happens here? Is this ever
It's
going
gonna
to
be
be?
wrong all the time.
Yeah, it's gonna be wrong all the time because that means they both have to be satisfied. Is there any shortcut evaluation in here?
Well, I mean.
If date-
Cause it's gonna check both.
Is it going to check both of them? So we're looking for a true. The second we find a false, we're done. That's short circuit evaluation.
6 then. So-
Right, so if date 1 is false, we still are gonna check date 2. What condition does date 1 have to be in? And we're not gonna check anything else, because we're looking for true. We're looking for true. So if date 1 is 6, we're done. We don't have to check the next one. Sorry, I'm saying it backwards. You're right, Owen. If date 1 is false, we're out of there.
Say it's gonna keep.
Yeah, I'm
checking.
sorry, my brain got upside down. If date 1 is false, we're done. Because there's no way they both can be true. Just by testing. Sorry, I got my brain upside down. So and and or are your most common people. Aren't we glad there's not many more? Oh, no. What if we do this? Well, that's not right. If I put that here, I think. Yeah, there we go. What does the exclamation point do? In Python, it would literally be a word, not, N-O-T. And you'll see this in code, and I try to avoid this as much as possible because I think it's confusing. This means if date 1 is equal to 6, this is like saying if date 1 is not equal to 6. So it negates the current testing. I try to avoid this at all costs because it's, I think, confusing to look at. But that's what that means. If the date is not equal to 6, it's true. This means if the date is equal to 6, it's false. You can also do this. That means the date is not equal to 6. And you can't always avoid that. So far, so good. So we have the not, we have the and, we have the or. We also will see, did I do that in here? You'll also see. Or I don't have it in here, do I? It's in another program. But you'll see something like if. and there's no comparison statement. What is that asking? I like to be explicit. This is what's called implicit, meaning it's implied. What is this asking of this? Is it asking, is this true? Is it asking, is this false? Because this is a Boolean, true or false. What is this saying?
If it's true to that.
Yep, it's an implied version of this, and I say just put it in there. But you're going to see this in people's code, and that's what it means. If is weekend is true. So that's an implicit test. I like explicit. I think it makes it easier to understand, but then I'm not an advanced coder either. I'm, usually doing these kind of programs. So far, so good. You will see that. I like being explicit myself, but that's me. Doesn't mean everybody else is going to do it. Oh, I do have an example in the next tutorial with the logical operators. Yep. Whatever that one is called. Then we have a very important one for everybody. This has been scientifically tested and studied that this app gives you the truth. This is nothing fooling around about this. If you date in or outside of this app, you're in trouble. Right? Yeah, I don't think so. I have my parentheses and my commas in the wrong place. So this is a simple little thing, but it's just a getting started with. I always thought this was funny. Like somebody call it the creepiness rule. So they have to be at least 7 years older than half your age. Right? So if you're 18 years old, they have to be at least 15. And this is the result. Can you date somebody older than you? What's the range? Can you date somebody younger than you? The dating dilemma. Aren't you glad to know there's a scientific way to figure out that, right? Okay, I think it's funny. Is it a silly program?